Coke floating around. I'm just spoiled. I'm spoiled up here. Okay, so we're going to talk now about our very first stormwater control measure design, and it is rainwater harvesting. All right, and I just added. I'm a believer in just-in-time presenting. I've added pictures I took today to this presentation. You'll see it in a little bit. But let's go ahead and right off the bat acknowledge that there is a long history, an ancient history of really cool water supply right here in India. All right. I've been to this one step well. It's remarkable. If anyone knows of other step wells that they're like, Bill, you should visit, let me know, please. Okay? Because I would love to visit them in a future trip to India, unless there happens to be one in Kerala, and I'll go see it in Kerala when I go there next week. All right? But essentially, rainwater harvesting initially was used as an alternative water supply. Okay? Now we have turned it into a prospective stormwater control measure, so it's something to help stormwater treatment as well. But initially, it was just a form of water supply. Now the Romans, and some of y'all know that I'm a big fan of Roman history. I teach a class in it. And anyone familiar with Hadrian's Wall? It's the second longest wall on Earth after the Great Wall of China. And it's about 130K. It's pretty long. It's about 130 kilometers long, and it more or less separated England from Scotland. It's not quite true, but it's close. Separate England from Scotland. And the Romans built this wall so that they could look at the Scots and make sure that they knew who was emigrating, who coming into England. Okay, they didn't keep them out, but it allowed a more controlled flow of people into England. All right. Of course, they also didn't trust the Scots, and so they built these forts. All right, you can see an example of one of the forts, what's remaining, and the runoff from this fort, okay, actually went down to a lower corner where the Romans captured the runoff in a tank. And then they used the runoff from the tank. You guys might recognize that guy. That's Fernando. He came down with me. The runoff was kept in a tank, and you can imagine wooden benches placed here with holes, all right, discreetly, like holes about that big, all right, discreetly placed on the wood. Excuse me. I apologize for that. I swallowed funny. And then what they would do is they would open up. Excuse 1 second. You don't need to hear this. This is gonna. Sorry, guys. I know this is going to sound weird. I swallowed my spit weird. That's a great idea. You're like, I was watching my professor and he fell out coughing to death because he swallowed his spittle. That should be better. You guys could have laughed. That was all right. It wouldn't have hurt my feelings. Okay. And so they had this water in a tank. They had basically turned this into a toilet. And then every once in a while, they would open up a sluice gate and the water would flush through the toilet bottom and flush the human refuse out. So the Romans were harvesting water to flush toilets 2,000 years ago. Well, I found that particularly interesting because at the time I was trying to do a research project in the United States, trying to convince local authorities to let me use rainwater to flush toilets. You know what the local authority was telling me? No. I'm like, what do you mean no? The Romans were doing this 2,000 years ago. So rainwater harvesting in some parts of the world has become actually very popular and has been popular for a while. Principal among those is New Zealand, and Australia. Okay. So I'm going to show you some examples from New Zealand and Australia. I did my very first sabbatical in 2010 in New Zealand, Australia. It was very educational. Um, Here's one, a nice big tank. You notice right off the bat that they painted these tanks. Um, that's not something that I, as an engineer, would ever have thought about, right? But can I tell you one thing that I would figure out as an engineer? I'm gonna look up here. This case in New Mexico, you see where they're dumping the water? Like they're missing the tank. You see where the downspout comes? This is where, that's where it's supposed to go. My vertical is not very good. It hasn't been good probably since I was 23. I have a really bad vertical. Rainwater harvesting supplies all the water in certain communities in New Zealand. All right, all of them. Here's one in Australia where this, I don't call it a canopy or whatever. This is the catchment for the water, and it goes down through this column, and the tank is actually beneath this fish. This is in Chinatown in Brisbane, Australia. And then what the city officials do is they take water from the tank and they use it to irrigate plants in and around the neighborhood. All right, pretty clever. There are vendors in Australasia that one of the big things that they're trying to promote, you can even see the sign, tanks sold here. So rainwater harvesting, just understand, is a very popular, in fact, in New Zealand, it's almost a mandatory practice just to have a water supply. There are large shopping centers. They'll have big displays as you walk in. And we don't have this in America, but this is what they have in New Zealand. Big displays as you walk in saying, here, buy our tanks. All right. I went ahead and I looked up how easy it was to get tanks here in India, and it looks like it's pretty easy. There's a lot of, and this is just the first 4 that popped up on this India Mart that I looked up. There were just boom, 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 rows and rows and tons of tanks. All right. The first 3 you see here are all below ground, and that can work well. And I'll talk about this a little bit later, but where they're going to work is where you don't have, where you use them is where you don't have seasonally high water tables. If you have a high water table, then the below ground tanks are not particularly good. But if you do have a high water table, then you can use above ground tanks. All right. And in eastern North Carolina, the part that borders the Atlantic Ocean, we have a high water table. And so most of our tanks down east are all above ground. I know for an absolute fact you can get a hold of tanks here in India because today, this morning, we saw 3 different tanks outside the Water Resources Planning Building, Planning and Development. Is that correct? I just want to make sure I get the name right. But there they are, 3 different tanks. Cumulatively, they claim the system has 3,000 liters of storage. All right. That's probably about right. I'm sure that's right. So there's 3 different tanks, at least 2 different manufacturers, perhaps 3 different manufacturers. And it's quite close. If you want to look, well, in fact, we'll go look at it later, but it's really quite close to where the lab is, where we'll be meeting this afternoon. Okay. Now, Australia and New Zealand, the reason they're used so much, and again, in New Zealand, it's because a lot of people live in rural New Zealand. They don't have access to city water. And as a result, then they don't dig deep wells. So they harvest rainwater for all of their supply. In Australia, in 2010, they had a massive drought that had been going on at that point for something like 8 years. And in the local, well, the provincial or the state government passed a law that you had to build rainwater tanks because they were so low in water supply. All right. So there are 250,000 to 1 million rainwater harvesting systems in Queensland, Australia alone. All right. So if you, the closest place I can think of that's going to have a lot of technical guidance, I mean, geographically to India, I think it's going to be Australia. So that's probably where I would go. In fact, as an American, we look to them sometimes. Certainly, we did about a decade ago as we were creating our own rainwater harvesting design guidance. Okay. North Carolina, we do have the same situation. We have massive droughts. This is our reservoir. We pull our water out of reservoirs, much as what happens here too. That was our reservoir, and we were getting really close to running out of water. And as a result, we also started putting in tanks as well. I'm going to show you some of the tanks that we have in my home state. What do you think one of the principal uses for harvested rainwater is? You see it right up here. Irrigation. Irrigation is probably, I'm going to call it the safest use, or one of the safest uses for harvested rainwater, because you're not trying to drink it. Okay, so you don't have to clean it so much. You're throwing it onto vegetation, especially if it's rooftop water. Rooftop water tends to be relatively low in toxic metals, but pretty high in nitrogen, and they have some phosphorus in there too, but relatively high in nitrogen. And so you know what grass and vegetation likes to have? Nitrogen and phosphorus. That's why they're called fertilizers. So if you guys want to know a new word you can impress your boyfriend or girlfriend or loved one with, the word is fertigation. Fertigation. You know what that means? It's a mixture of two words. Fertilization and irrigation. So when you pull water and apply water from a rainwater harvesting tank, you put it onto a crop or plants or your tree, you're actually fertigating. You're not just irrigating, which is pretty cool. So here's a tank in Goldsboro, one in Greensboro. You can see most of our tanks, most of the ones in the United States are black or green. We also have some that are translucent that I'll share with you. Here's one that's below ground. And a lot of times, if it's a really big system, these below ground ones make a lot of sense. And here's another one that's going to be below ground as well. All right. So rainwater harvesting above ground or below ground, often or typically opaque, so that sunlight does not penetrate into them. As if it does, then you'll have problems with algal blooms. Here's one there's a big, that's me partially hugging a tank. You'd see how big they can be. That's probably about a 10,000 liter tank. It's a big tank, 10 to 12,000 liters, one tank. And so we do use that, and that particular tank is used to fertilize a soccer field, or you might call it a football pitch behind. So again, the use of these tanks is grown particularly from a fertilization and irrigation standpoint. Now, I do want to point out that if you look at the average, and this is probably more of a unique thing to the United States, but and I did not take the time to convert everything to liters, but I did put the conversion up there for you. So roughly multiply all these things by 4, and you'll get an idea of what these numbers are. But the point is that your average American household uses about 400 liters a day for non-drinking, 400 liters of water for non-drinking purposes, right? And if you're looking at rainwater harvesting, then you can replace all of those non-drinking purposes with harvested rainwater, all right? And so that's just something to think about as a motivation. And the reason that's important is it can actually save people money, all right? So rainwater harvesting is unique in that as a stormwater control measure, it actually pays you back because you're saving money. Otherwise, we have to buy water from the government, all right? The government supplies us water, admittedly, at a very low price. We're very lucky. the government supply water at a very low price. And of course, they do it because that's to the health of its citizens, right? But they supply water at a very low price. But you can forego paying for water and harvest it yourself, all right? And that can actually save you money. And so that is one of the unique things about rainwater harvesting as a practice is it actually partially pays itself back. So let me talk a little bit now about how well rainwater harvesting works. We'll show you a couple of studies. So here's a sort of a classic case. We have a rooftop. It leads to this tank. This is the bypass. If it fills up, the water will go down there. And this water was used for the most part for spot irrigation of shrubs and trees around this office. So there it is, some spot irrigation going on. Now, what you see here in this line is the water level inside the tank. All right? Now, what do y'all observe? And you're looking at the water level here. What do y'all observe about the water level in the tank? What's one thing that jumps out at you? This is over the course of, well, over a year and a few months. What do you observe? You're about right. Just say it. You're going to be right, Omar.
April to June is
like it. They hardly used it. Yeah, that's what you're getting at. That this tank ran full most of the time. Okay. And that's been one, and you'll see why this is important. All right. So here's case number one. The tank wasn't all the time full, but only a few times did we even get around 30% or 40% of capacity. Most of the time, the capacity was up near 100. And so why this is important is that the use of the tank was not automated. We relied on people, all right, to withdraw water from the tank. Okay. Let's try again. That was one example. Here's another one. This one here, this is a very big tank. 5,000 gallons, about 18,000 liters. Okay, big tank, 19,000 liters. It was used, there I am, it was used to wash vehicles. Now, that's me washing my vehicle, but I want you to know that I don't work there, okay? I was just visiting and washing my car. Well, take a look at how much this water was used. What's the answer? You're like, not much, Bill Hunt, not much. That's right. So again, this was and the reason it wasn't used that much is that the city already had a wash station, like, I don't know, 10 meters that way. And so the city in its mind wasn't using the harvested rainwater wash station. It was just using the old existing wash station. Now here's another one. Now this one here was at a education building, and it was used, you ready for this? To flush a toilet, okay? Now, this one at least, you don't have to ask people to remember to use it, right? People know to flush a toilet. And this is what we found. What do you see here? It never got close to being empty. So that meant all three tanks, I'm going to ask you this, all three tanks, were they bigger than they needed to be? You guys know the story of Goldilocks? Goldilocks and the Three Bears? Goldilocks, they went in and had the porridge. Oh, this porridge is too hot. Oh, this porridge is too cold. Oh, this porridge is just right. You guys know that story? I think it's a German tale. Goldilocks. In fact, I guarantee you it's German with that name. All right. Well, are these tanks too big? Are they too little? Or are they just right? How many of you like they're too big? How many of you like they're too little? I'm like, they're just right. You know what I would say? They're too big. They're too big. Because this one here could have been, if I didn't ever want to run out of water, could have been 40% the size based upon how they used it. They're too big. But what does that present us an opportunity with? Either to shrink the tanks or to do something else with the water. All right? So remember that. We're going to come back to that in just a little bit. What else can we do with this water? All right. So at the same time we were doing those studies, we had this one study down at the beach of North Carolina. We have very nice beaches. I'm looking forward to seeing the beaches of Kerala because I've heard that they're lovely. Have you guys ever been to Kerala? Has anyone here been to Kerala? If you have, let me know, and I'm always game to hear suggestions. And so what they did in this town is they took septic tanks. You guys know what a septic tank is? If I say septic tank, thank you. So a septic tank is where your sewage is going to get stored, right? And the way a septic tank works is you have a bottom piece, if it's made out of concrete, bottom piece and a top piece. So that's how they put it together, all right? There's a bottom, and they bring in and they put in a top. You're looking at the top, all right? And what we did here is we had water directed from the rooftops into this tank. So there's your downspout. All right, you're gonna be, hey y'all, you're gonna be looking for downspouts during our tutorial session this afternoon. So get ready. You're gonna be downspout spotters. All right. Downspout, and we took that downspout water and we routed it into the tanks. So we converted these septic tanks, which had never before been used. All right. So we weren't like, we didn't have to worry about cleaning them or all that. They had never before been used. And we took the storm water from the rooftop and filled up our tanks. And then they used that water to irrigate. So here it is. You can see the water being the irrigation point right there. And there's Mr. Smith, and that actually is his name, Mr. Smith, irrigating his tomatoes. Mr. Smith loved his rainwater harvesting system. He said that his tomatoes were the juiciest, reddest, and biggest he had ever had. Now, I don't know if it's because he was fertigating them. I don't know. All right. Now, let's take a look and see just how much water Mr. Smith used to irrigate his tomatoes. And the answer is everywhere you see a sudden drop, that's where Mr. Smith fertigated his tomatoes. What do you see? Let me ask you this. How much water, just relatively speaking, how much water did Mr. Smith use to irrigate his tomatoes? A lot, a little, somewhere in between. You see those little drops right there, those little red drops? Proportionally speaking, and that might have been a lot for him, but compared to all the water he could have used, he didn't use that much. But I know you can't see because I'm in your way. Try this, see if it's a little bit better. Did the water level decrease in the tank outside of Mr. Smith's use? You guys feel lonely? I'm gonna go over there and be with you. I don't ever go over to see you. I'm always over here. Feel better? You're getting scared. I know you're good. Okay. What happened? What was happening? The water level was going down slowly. By the way, see those two spikes? That's when we had typhoons or hurricanes. They hit there, and that's why the water went up real high. What was happening? Remember I told you about those tanks, septic tanks? There's a bottom and there's a top. And they're both 2 feet or 24 inches inside. So it's a 4-foot, 1.2 meter tank. There's a bottom and there's a top. What was the water doing? It was leaking out the seam where the bottom and the top met. 2 feet, 0.6 meters, 24 inches. I know it's in English units. I'm like, I'm not going to take the time to go through this. You guys are going to be fine. All right. The water leaked out until you can see how it almost was going asymptotically. That line is at 24 inches or 2 feet because that's where the seam was between the top and the bottom. So what we had here, a lot more, Mr. Smith used some water, but most of the water got used, well, actually wasn't getting used. Most of the water that left that tank was leaking out the side. And I thought, I wonder, what's that? The blue is the rainfall. Yeah, those two monster rises, those are storms, those are hurricanes. Blue is the rainfall. So I was like, okay, this designing a tank to leak might actually be a good idea from a stormwater management perspective. From a water supply perspective, it's probably not good. But you know what? We had plenty of water. A leak seems to make sense. I went to New Zealand. And guess what New Zealand does? They literally put holes in their tanks on purpose so that it has, ready for this, a slow leak. And the reason they do that is because it helps them manage stormwater runoff. All right. So there you go. They dedicate a fraction of their tank to managing stormwater runoff. And then the bottom portion that's beneath the orifice, that is reserved for rainwater harvesting. All right. So after that, we decided that we were going to test an intentional orifice or hole in the tank with this. Now, this one, fortunately, I have an SI units for everybody. And there it is. There's your leak. All right. 35 was the top one. That's good. That's the one I recommended. 17. 17. Okay. So this was a little bit less. Well, it was less, 2/3. 2/3 of that 17 water quality volume. All right. And then everything beneath it. And we also designed it so that it would draw down, if it was full, it would draw down over the course of 3 days. And this is what was used. This is actually associated with beer making. I noticed that beer is not a huge part of the culture here. It is in America, for better or for worse. All right. And I got a buddy who likes to brew his own beer. That's a thing. And for the record, it's pretty good. It's pretty good. All right. So anyway, this is associated with brewing, but it has these really small holes, all right, that go into that larger tube, and then that's used to basically make sure clean water is leaving this tank. So there it is, and there it is leaking. the solid black line. That means that DOT, our transportation folks, were harvesting that water for whatever purpose they wanted, irrigating. They actually use the water to suppress dust. Okay, and if you apply water, you can suppress dust. All right, and so that's what they were doing most of the time with it. What do you observe is going on here? Which one of these two methods of withdrawal is more important? That associated with the leak, or that associated with the DOT using the water to suppress dust? Well, you can figure it out by summing the amount of water withdrawn both ways. About 100,000 liters was released through the slow leak, and about 60,000 liters was actually utilized. Okay? This is in line. I put 12 here. But so we had 11 millimeters that we set that detention volume for. What if we set it to 25 millimeters? What if we set it to 17 millimeters? What would have happened? We'd have had to lower the hole would have been lowered. So we dedicated more tank to water storage from a rainwater harvesting for a stormwater standpoint, but it would have worked even better, right? So here's one of the really important design considerations that you have. Do you include the low flow drawdown? And then where do you put it? Do you put it so you capture 17 millimeters? You try to capture 30 millimeters or 35 millimeters? You capture less, more? And the answer is, we'll find out later. All right. But you do have that ability to put in a slow leak so that it does more to help stormwater management compared to just applying rain. And I'm gonna talk about it with rainwater harvesting, but this technology actually has great possibility if you use it with wet ponds. If I do a Trump impersonation, would you guys find that funny? Would you, if I did that, would you laugh or not? I like impersonating presidents. I think it's funny. Obama, Bush, Biden. This is my Biden. But I can do Trump. I'll do Trump for you in a little bit and see if you guys will laugh. It'd be the best impersonation ever. It's fine. Okay. So active drawdown. Active drawdown means that you are managing. I bet you they can predict weather too. Okay. And so it's based upon prediction. They'll say, how much water are we expecting to receive in the next 24 to 30 hours? All right. And then based upon whatever that answer is, you decide whether or not your tanks have capacity to capture it. All right. So here's a bunch of tanks all along a wall. All right. And you can use the water from the tanks to irrigate this. There's the garden. But you also have the ability to release the water in advance of a storm. And that's what this does. So you can imagine the tanks having a smart control. And the smart control speaks to the National Weather Service or your meteorological prediction agency. All right. And it will basically be communicating every hour. Hey, how much rain's going to come in the next 30 hours? Nothing, 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 nothing. 18 millimeters. Ooh, 18 millimeters. And so then, as soon as it learns that it's 18 millimeters, then this smart control talks to the tanks and says, hey, how much storage do you have? We've got 6. Water, the valve closed, and now we've got 18 millimeters of storage, and then we wait for the rain. Might sound crazy. This has been going on. This study here is 15 years old. 14 years old. I'm going to show you how it works. Oh, I should also point out that when you release the water from the tank in advance of the storm, you can put it different places. What we try to right? In addition to the sundial, they also have drains, downspouts. All right. If you had put where my buddy Sean is pointing, if you could have intercepted that stormwater runoff up there, not that I'm proposing to do that, but if you had, okay, you'd store your runoff. And then if you're going to release it in advance of a storm, guess what we got? Right in front of it, we have a prospective infiltration zone. All right. So essentially, that's how rainwater harvesting systems, not that this place needs it, but if you actually wanted to have a really cool demonstration site, this might be a neat one to do. A neat demonstration site. The courtyard of the Thompson building is actually set up perfectly for a rainwater harvesting rain garden dual setup. It's like, I mean, these areas are actually sunken. These beds are actually sunken. They could easily be converted into rain gardens. All right. So just understand the same idea you could do right here at Rookie. All right. So Hurricane Sandy came. This is the elevation of the tank before Hurricane Sandy hit. All right. This red is the predicted amount of rain that's coming. All right. And so what they did is like, okay, it said, hey, you need to draw your water down. And so it did. It drew the water down. And then it's, oh, the rain's even bigger. And then it drew the water down even further. Now, why do you think it didn't de-water the tank? Why didn't all the water get discharged from the tank? Because the rainfall prediction was you needed to acquire all of that space to capture the rain that was going to fall. What do you think the difference is with a tank that has 3,500 liters in it versus a tank that's empty in terms of weight? There's a big difference. All right. Water is heavy. When a typhoon hits, do you call them typhoons or cyclones here? Cyclones? When the cyclone hits, is it just rain? Nope. What else is there with the cyclone? Wind. Right. Imagine having a bunch of tanks that are completely empty and wind comes. Does that sound like a good idea to you? It's a crappy idea. That's right. So that's the reason why they don't take the water all the way down. It's because from a true operational standpoint, you need those tanks to be heavy enough that the wind won't blow them around, okay? And so that's why you saw the elevation get down to this point right here. And then guess what happened? It started to rain. And then the rain came and filled the tank right back up. And y'all, that is how an active control tank is supposed to work. And here it is in action. And you can see a sudden drop and then a sudden fill back up. That's because it's releasing the water in advance of the storm. And then within 24 hours, it rains and it shoots back up. Now, there's a couple of times where it wasn't quite. So this one, they thought the storm was going to be really big. And what happened? The storm wasn't that big. It only filled it up a little bit. But then the next storm came and filled it up more. Okay? So it's not like it's perfect. It's not like the predictions are perfect. We know they're not. But you do get some idea about how an active control system. Now, to make it work like this, if we were to do it off the shelf and buy this proprietary product, it would cost about another $25,000. That's too much money for a rainwater harvesting system on the side of a building. But $24,000 isn't too much money if you're designing a large pond that treats 30 hectares, okay? And so really where this technology has its most application is in larger basins, all right? But I did want to share it with you here from our study. And I also will point out that you'll see right here, it goes down to 0. If people have been actively managing this, they look at that and say, why is there 0 water in our rain tank? It's not like it's not raining. And the answer is, whoops, a squirrel. You have squirrels right here on campus. It wasn't that type of squirrel. It was one of our squirrels. A squirrel had gotten in and chewed a hole in the tank, and it dewatered the tank because of it, all right? So one advantage of this system, guys, is that if you're actually looking at it, you say, oh, that doesn't make sense. Why is the water level at 0? It can clue you in to go inspect it and see what's up so that it eventually gets fixed. This is a point I want everyone to have for going forward, all right? For all the different stormwater control measures, that if at some point you do get to active management, one of the big reasons to have active management is to better inform maintenance. So in the first presentation, I talked about how important maintenance was. Now I'm coming back to it and saying active management helps you have more efficient maintenance, all right? But you do have to pay for that. You do have to pay up front in technology. All right, let's see what we got here. The same thing was done. I'm going to skip through this, but it's everything I just spoke about. The same thing was done with large ponds at University of Central Florida. Same idea. All right. Now, rainwater harvesting is not, or stormwater harvesting is not a practice that has to be used in isolation. Okay. Any practice that filters the water and then discharges it after it filters it can be used in front of rainwater harvesting. Okay. So there is a term that we use for this in the US, and it's called a treatment train. Y'all ever heard the term treatment train? It's a treatment train. So you got a train cars, okay, of different treatment systems, different stormwater control measures. All right. So a rainwater harvesting system can be used as the caboose, the last car of a treatment train. All right. And so the two most common ones to use for that would be bioretention or permeable pavement, both of which filter the water, and then the filtered water would actually go into the tank. I'll show you an example that we did in Ohio. So the water flowed onto permeable pavement, okay? It flowed through the permeable pavement, and then inside that permeable pavement, embedded in it, was this rainwater harvesting tank. It was a below ground tank. Again, I'm not sure that this technology could be used in large swaths of Rookie, but there are others of you that work in places where the water table is not within 2 meters of the surface, that you would be able to use a technology like this. All right. So I just want you to be mindful of that. So here it is. You can see the run on, you can see the permeable pavement, and then the water would flow from the permeable pavement into these tanks where it would get used. Okay. Now, the advantage of having the water flow through the permeable pavement first is that the water would get cleaner, all right? Which means that you could then use that water for more things than if you use raw runoff, okay? Especially when you have a lot of vehicles driving over. That's pretty dirty stuff. So the permeable pavement, in theory, would clean the water. Now, let's just see how much water it actually cleaned right here. So the big box, that's the night. This is the yellow stuff, or orange rather. That's the inflow. And the cistern water quality is the light blue box plot right here. And then the drainage water are these little blue, darker blue spots. All right. So the drainage water is actually what was being pulled from the tank. All right. So that's the end. The cistern itself, the rain tank, actually employs sedimentation. All right. If water's in the tank, particles are also settling out from it. And then the water that's being withdrawn from the tank is generally this lowest of concentrations, these little blue boxes. That's the concentration that the water got pulled from. So what do you see this treatment train doing? It's significantly reducing the pollutant concentration and therefore the load, so that by the time you use this water for whatever purpose you have for it, the likelihood that that water will be sufficiently clean has just gotten much higher, all right? So remember, rainwater harvest, and when I teach this stuff, y'all, I do kind of focus on one practice at a time. We talk about rainwater harvesting today, talk about wetlands on Thursday, talk about bioretention on Friday, but the reality is they can be mixed. And the one that's most easily mixable is rainwater harvesting, okay? Either beforehand, where the water drains to a rain garden when it overflows, or where the water will get treated by a bioretention cell or permeable pavement and then drain to a rain tank, underground tank, which can then be used. All right. So just remember, again, you got to have a water table not near the surface to pull this off. All right. How big do they need to be? All right. The answer is it's a balance of supply and demand. All right. What is our supply? What dictates our supply? There's two factors that you would use to calculate the supply provided on a given day. What do you want to guess there? What do you think one of the factors is? How does water get supplied to a rain tank? What does it have to do? Let me ask you this way. Is water being supplied to a rain tank today? How many of y'all say yeah? I'm like, no. No. If it's not raining, it's not supplying water. All right. Typically. And so to determine your supply, you've got to know the footprint that the rain falls onto, boop, multiplied by the amount of rain you get. All right. That's how to supply it. That's pretty much it. Okay. North Carolina is here. All right. The wettest part of the country is actually right, not including Hawaii. Hawaii is the wettest. I think the wettest part of the world is in Hawaii, on Kauai Island. But this is the west part of the United States. But you will observe that it's also very wet right in here. All right. And this is our, and then, and just forgive me, everything's in inches, but remember, that's 25 millimeters, 50 millimeters, 75 millimeters, 100 millimeters, okay? 4 inches is about 100 mils. And it rains every month. That's, well, I'm gonna have a question for you in a second. That's North Carolina's average supply. What do you think is happening here? July, August, September? That tends to be when we get our hurricane strikes. Here's Rookie. June, July, and these are big, big numbers. 280 millimeters. June, July, August, September. Clearly, I picked a good month to come if I want to come when it's dry. All right. So do we get a lot of water here? All right. In fact, this distribution and this distribution yield almost on an annual basis the exact same amount of water. This is this is about 1,300 millimeters. Not that you'd know that, and that's about this has 1,000 millimeters. Which of those two rainfall patterns would you rather have if you're going to operate a rainwater harvesting system? I want everyone to think about it. There should be an N on that word, not just pattern. Would you rather have that one or that one? What do you all think? How many of you would rather have the pattern in North Carolina? How many of y'all would say, oh, I like my Rookie rain? Okay, you were correct. And why is it that the North Carolina weather pattern is basically better? Nothing you can do about it, right? Nothing we can do about it. Why is the North Carolina weather pattern better? What's that? It's more regular, right? And therefore, if you need the water in, let's say, November, okay, that water has been supplied in October and November, all right? It's not that there's zero water, but there is. November, that's really dry. That's like almost freakishly dry, all right? But even October, there's not a lot. I mean, what is that? 15 millimeters in the whole month? There's not a lot that gets supplied right now, all right? The good news is at any time of year it rains, you probably do have a use for the water, okay? So, but the second thing that's going on with this weather pattern, what's happening in July? You're getting a lot of water. What's the use of water that I talked about is most, we'll say, the most obvious use for harvested rainwater, where you don't have to treat it too much? What is it? Irrigation. Let me ask you all this. How much irrigation would you need to do in July? Do you need to irrigate anything in July? Yeah, you got 290 millimeters of rain falling in July. You don't need to irrigate jack. You need to irrigate in August? Nope. You got 245 millimeters. That's a lot of water. So one of the issues here is that certainly in July and August, and I would argue certainly a part of September, you would actually never need to irrigate because you just have so much water, all right? Which means that you would need to find another use of water, okay, for harvesting tanks in Rookie, okay? You cannot rely, doesn't mean you don't have any irrigation. You can certainly make a tank that irrigates, the water is used to irrigate, but you have to find other uses. So this is the supply. What do you think the other uses? What category does other uses belong in? What's the opposite of supply? Supply and demand. Okay, so now we need to think about the demand, all right? And rainwater harvesting works best, ready for this? The more clever you are. All right, we're gonna take a quick break here. And I want everyone to tell me in English, how do we spell engineer? Because all of you are engineers, almost all of you. We have one geographer. How do we spell engineer? Someone tell me. What's the first letter? E. Engineer. Engineer. And what does that connotate to you? Engine. And it's appropriate because we tend to work hard. All right? Engineers are hard workers. All right, where's my man? My University of Trento. Do you know how do Italians spell engineer? It's ingegnerio. What's the first letter? I. For ingenious. Okay? I hate the way English spells engineer. I hate it. Not that an engine isn't appropriate, but engineers really are intended to be ingenious. Okay? So here come, I mean, seriously, I'm not just making, like, for real. So here's our chance to be ingenious, to practice ingenuity. All right? What other ways can we use water for our demand so that we can find a place for this water to go in July, August, and the first half of September? Okay. And here's the answers. Irrigation, you can flush toilets. All right? You can wash vehicles. You can wash clothes. Swimming pools are not super popular here, but if you treat it, you can fill a swimming pool. You don't have to do any salt brine application, but if any of you, I mean, in northern part of Uttarakhand, you do get snow, right? If there was a highway there that they wanted to make sure that snow melted, you could add salt to it. You can use it in street sweeping. You can wash pet cages out. You can fill aquarium tanks. This is my call to you to be ingenious. Think about what your demands could actually be. All right. One possibility in this world of being ingenious is if you treat it right, you can drink it. Now, it does cost more to get it to that level. But one thing I know for a fact is that if you can drink your harvested water, you'll always have a use for it. All right. If you can bathe in it, you'll always have a use for it. If you can flush toilets with it, you'll always have a use for it, whether or not it's rainy or not outside. Okay. So just remember that if you provide enough treatment, you can bring it inside, and that has a big impact. All right. I'm going to go through that. The way you calculate how much water is available in a tank is you take a look. If you have, well, you can look at it. The idea is every day you've got to calculate based upon the demands if you have an adequate supply for the demands in that tank. Okay? So you have a starting volume for the day. If it rains at all that day, you add that, all right, to the starting volume. And then you also at the same time look at what your withdrawal from the tank is going to be. And essentially you just do that. And it's pretty simple, except you have to do it 365 days a year, perhaps 24 times a day for 10 years. Is this a calculation you want to do by hand or even with a spreadsheet? You got it. This is a calculation that is intended to be used by or made by a model, all right? And the last thing I want to mention on this realm is you've got to establish what your demand actually is. That's not terribly hard, all right, if you're flushing toilets with it. But let me argue this. In North Carolina, did we do a good job of determining demand in those first four examples I showed you? And I would argue we didn't. We didn't. Why? Because the tank was 60, 70% this is my, you have to stop soon alarm. 60 to 70% full at least all the time. We didn't intend for those tanks to be that full. We just did a bad job early on of understanding what the demand was. We have a much better idea what demand is now, okay? And even then, we don't quite get it right. So one of the most important things you're gonna have to do is you're gonna have to look at what your demand is and have a good sort of confident feel that the demand calculation is close to being right, all right? That's gonna be an important take home for you as we figure out how big those tanks need to be. So the best way to determine how big a tank needs to be is, in fact, to run a model. It is a perfect time for us to stop because we will talk about the size of a rainwater tank and running a model this afternoon. You guys have any questions? Okay, so it is a little bit after 12:30. When are we supposed to start back up? 2:30? 2:30? 2:30? Okay. Well, that means you get a nice little break for lunch. 2:30 is a good time. That gives me, we're in good shape. What we're going to do to start off is we're going to walk on campus and we're going to identify a place. We're going to take a look at a spot that we have identified where rainwater harvesting could help. Okay. And then we're gonna just identify some stuff. We'll also see part of a rainwater harvesting system that was already installed. We'll go see this. I showed you some pictures of it. And then we're gonna come back and we're gonna run the rainwater harvesting model as a group exercise to figure out how big the tanks need to be. All right. And then after we do that, I'll have a couple more important design factors, I think, for us to include after we figure out how big the tank needs to be. And then we'll call it a day. All right. So that is what is between us and 5 o'clock this afternoon. Sound like a plan for everybody? All right. So we have almost 2 hours, not quite 2 hours for lunch. Hope everybody enjoys your